Right, good afternoon grade 11. This is now the second lesson or second installment of the development series. The first one you can just go have a look at already, introduction to developments, interpenetration and development. Today we are looking at a branch pipe that's on an inclined plane into the front view. So your instructions are as follows. An incomplete front view and top view of two right regular solids penetrating each other. Complete the front view showing the curve of interpenetration. Draw the development of the branch pipe using starting point AA as the seam. There's the starting point. And then show all construction. Starting off again, copy piece. You guys should be well versed in drawing this at this point. If you are not, please go have a look. I have a video on how to draw a hexagon, pentagon and triangles on different angles. That should assist you quite a bit. Alright, so once you have this copy piece done, then we can start looking at the interpenetration that's supposed to happen here. So having a look at the information that we have on the front view, we have to measure 8 millimeters here. 8 millimeters. You bring this line up to there, and then it's a 45-degree angle where this branch pipe is penetrating this main pipe. So 45-degree angle that you measure out. So on this line, this is now going to be this line of the branch pipe. I don't know what this width is, so that means I have to redraw an auxiliary view for this front view specifically. So from here, as close to the top as I can, I'm going to start with this line, right? You can see it's a normal square that you would have drawn even though it's on a 45-degree angle. So I'm going to start by drawing a line going up, which is going to be this vertical line, and I'm going to make sure it's 25 millimeters. Okay, so it should be more than enough here. So in a construction line, I'm going to draw that line there. This might be too far up. The only reason for it can be lower, just as long as it's not going to intersect your branch pipe there. So this is supposed to be 25. Okay, normal square, 90-degree angles, nothing special about this. Okay, there we go, the bottom and the top. Alright, now we can go ahead, and we used a 45-degree angle, to project that point up. So that means from all of these points, you are going to project them down with a 45-degree angle as well. And here you can see if I project this point down, this front part, until it connects onto this construction line, in that top point that came down, it's going to be exactly the same as that point there. And now I can go ahead and measure 5 millimeters there, and then this will also be a 45-degree angle because it has to be perpendicular to the original angle that I used. So from here to there it's 5 millimeters and then a 45-degree angle. So here you can see the space that I basically have left. So this could have moved a bit to the closer or a bit further away. It would have been the same story. Alright, so once I have this, I'm just going to leave this hanging just for a minute because I would like to complete the top view first. So I'm going to project all these points down. Right, so this point, every point for the branch pipe, I'm projecting down. Because I now have to do this copy piece that I see here. So in the middle, you can project the line out, and on here we have to draw a square. Now you can already see the way this square is situated. I cannot draw the same square. It has to turn on a 90-degree angle, which means you are going to use the circle method again here, just like we've done in the first lesson. So now we take this base measurement and we halve it. So because it's the circle method to drawing the square, right? So 25, half of it is going to be 12.5. That measurement you can put in maybe just a bit more to the right, like that. Should be perfect. Draw in a construction circle, and now we use 45-degree angles on all of the sides, right? So a tangent, you draw a tangent here, tangent on the side here. Make sure it touches, it has to touch on the circle in order to be a tangent. Alright, so now you should have a square that has a base of 25, and we can double check this if we want, measure that and see, yes, that's exactly what we want. Now we can project these points in. Remember, you can pause the video at any point to catch up to see what you have to do. So the line that's going in here, there, up there, and down there is going to represent these 4 points. So only on the inside or the outside here, the top, and then on the back side you'll have an equality line, and then these points aren't on a specific angle, you just draw touching lines or connecting lines to the points, like so. Alright, so that would be your copy piece done. So here we can go ahead and say A, that means one of these 2 points will be A. I'm going to use this one. The same example as the previous drawing. If this auxiliary view, this point represents point A, and this one is going to represent C. I'm taking it onto point A, or on point A, and I'm lifting it up. So point A is closest to me. So that's A, B, C, and D. Now this entire top view is now falling over the XY, so it's then the front view, which means this line that comes down here is going to be point D. At the back of that you'll have B, A is going to be at the top there, and C is going to be down here, like we've already established. You can see they should now connect onto the same letters. So going to the auxiliary, that should be A, D is supposed to be here, B, C, D. Now we can go ahead and start doing the interpenetration that happens on the inside here. So point D connects there on the main pipe, and now it goes straight up onto point D. Alright, point A and C is going to be exactly on this turning point, or the sharp point of the prism, the hexagonal prism. So now you have this, if you have to complete the interpenetration here at the back. So this is point A going to A, C going all the way to C, D going to D, which is visible. B is also here, but it's at the back. You can see it's exactly in line. So now you can go ahead and just connect the rest of your equality lines. So that is going to be the interpenetration done and dusted. That's what you have. Just make sure these letters D, B, they correspond with the letters that you have here. If it does, then you are fine. Alright, then you don't have to worry about looking at all the ways that this drawing turns, and from the front to the top, and vice versa. So having a look at the development part now, we also develop the branch pipe. So just here on the right hand side, just do this. I'm also going to start with a vertical line. So in this case, again, the branch pipe is a square, which means I'm going to start on A, B, C, D, back to A. So you grab your compass, you put it on point A, you put it on point B, right, because I need the base measurement, and you start cutting it off anywhere here. So that's B, oops, so A, B, C, D, back to A. Okay, then we label A, B, C, D, back to A. Now we go ahead and we project these points up, because now we need to determine the length of the branch pipe. We've already now placed down the base. Remember, this base can be placed anywhere. Some people like to just take these points and project it on the angle that the branch pipe is intersecting into the main pipe here. But using it this way, it means you can just project it anywhere you would like. So now we actually start going from the base. This is considered to be the base. This is considered to be the base. So from the base you take the measurement. So A goes onto A. That means A goes to A. That's where the seam starts. That's part of my instructions. Right, so I have those two dots. Next one is B and D. They're exactly the same. So from the base to point B and D. So B and D. Then from point C is slightly, you can see C is going to be the highest point. So C. Now we have all those points. You can go ahead and you can connect your base. Right, so your base is A quality. Alright, then it goes slightly higher onto point C. So that is what the development is going to be. And now on the inside here, remember, please keep these lines as light as you possibly can so that you don't have to erase constantly. So on the inside we need folding lines. So it's a straight line, two smaller lines, straight line, two smaller lines, straight line, and so forth. Straight line, two smaller lines. So if you were to cut this out and you were fold it on these fold lines, then you would get exactly this square branch pipe that fits into this right regular hexagonal prism. Again, I hope this helps you. This is the second installment. We are going to look at some turning points in the next drawing, and then we are going to move on to cylinders. Right, there might be quite a few of these. They are designed to assist you to just use the knowledge that you already have from solid geometry and then just apply it again. Alright, best of luck and enjoy your day.